Welcome everyone, welcome to our Coreflux flash demo. Welcome to our Coreflux flash demo. Welcome! Yeah, simple.
Nice.
Hello everyone, my name is Tiago. I'm one of the guys behind Coreflux strategy, helping Coreflux bring the best product for your needs. And here I'm going to show you a demo, a test I did, just to test it out if we can do something that a developer needs. So I tried for myself to connect Coreflux to MongoDB to process data and store data. I did it for myself to test the product, but I'm sharing with you a quick demo and a small article for you to also be able to follow and do it for your reality. So, as I said, I'm going to showcase you how to connect to MongoDB data from multiple machines. Starting out with our documentation, a very beautiful documentation. We have here our routes, the way we connect to other systems. We can use to get data, send data, connect to machines, solar panels, everything you can imagine, and multiple databases and places to store or process data. And we have here our MongoDB route, and from here I'll be showcasing our demo inside the VS Code, our lot extension running deploying the logic. So here, starting with our VS Code, one of the things you can already see, it can support lots code, but also can serve as a documentation place. It supports Markdown. Here you can see we have an image showcasing the logic will be implemented. Just as a quick note, this type of content in documentation can also be generated with AI. I just passed all of this logic here to Gemini, asked for it to do a beautiful diagram and place it here. So it's a good workflow to also document, not only make it work, but make it sustainable. So what we'll be doing, we'll be generating data from two machines, energy data simulated, send it to the broker, then use a standardized model to process the data. Only one model. So what we want to showcase here is how we can connect multiple machines and then standardize that data with a beautiful data structure. And then store that data on MongoDB. I'm already running both Coreflux and MongoDB through Docker, a simple Docker, just deployed an empty broker and an empty database. So first step, let's simulate data. A simple action, I'm using lots to simulate data, but I could connect to any of these devices with a route to get real data. To simplify, I just simulated data. As you can see, it's very easy with lots. So, deploying data, and here our first test. Let's look at the broker, and we can see we have here raw data from two machines. The data is randomized, published every 5 seconds. Okay, simple, we have data. Now, let's look at how we'll standardize this data. We'll be using a model. Let me just comment this part. This is a tease for the next step. But here with the model, we can say, I want to add energy value, device name, and conversion of units, everything from data standardization, but as you can see, data processing. If logic, changing values, everything can be done here. But most importantly, I can use the logic of wildcards. So we can apply this model to any data that appears. So if I connect a third machine, a fourth machine, the data will appear with this standard structure without me needing to deploy and develop anything. It will be plug and play. And it will run as soon as we get data on this topic. So it's event-driven plug and play. So I deployed here my model, and what it is expected is to see here, as we can see, we have our standardized data. We have the structure, a well-defined structure of topics for UNS, and we have our information. And this information comes in two formats, a JSON format and a separate topic for each data. We know on the IT side, for databases, for systems, it's easier to have a JSON to integrate. Sometimes for integration with other logic, lot actions, or with machines, variable by variable, it's simpler to do. Our models do both. You choose what you want to do. And you can see here also the data from another machine. Okay, so on our broker, we have our data, a very beautiful data structure. Now we want to store our data. So first things first, we need to connect to MongoDB. As you can see here, very simple connection. Just a connection string like you do in other systems to connect to Mongo, and we'll deploy our route. And it is connected. But we now need to store the data. And going back to the model, we have this tiny piece of code that says, okay, so when the model runs, also store it in this table from MongoDB. If you wanted to store in another table, just change the name. In another database, change the name of the route. Simple, easy to adjust, and very simple. Data process, it's standardized, goes to the database. And it creates the collection. It's plug and play. Coreflux handles that for you. So now, to see if it works, let's deploy the model. Here, you wouldn't see anything new, but we should be able to see in Mongo our data. So let's look here at Mongo. I'm using MongoDB Compass. Let's look. We have our new collection in database, and as you can see here, we have our data. And adding every 5 seconds. We have the same data structure as we have in MongoDB, in MQTT Broker. You can see the different device names and automatically deploy. Okay, so as you can see, with 3 small snippets of code, we have a full integration of 2 machines or more, because this is plug and play, to MongoDB. So how can you do it for yourself and not only watch this video? You can do as I did, download a Docker. Let's see here, let's go to our installation page. Just run the Docker. MongoDB also has Docker for free. You can decide to run on the cloud. We have DigitalOcean, but any other system. You decide, you can run it wherever you want. You can follow this demo, this video, go to our website. We have also an article with this demo. And if you want to do it for your reality, you can go to our docs, see our examples, and cherry on top, you can ask our AI assistant for help. Here, just showcasing a new conversation. I want to know how to connect to MongoDB. So we are in the AI generation. We can go here and ask help for your reality. So go ahead, install Coreflux, install MongoDB, implement your logic, solve your needs. We're here to help you. Good luck.
How long do you think someone will take to replicate the demo that you made here? Is this a half-hour project, 3-hour project, 3-day project?
Yes, this is one of
yes
the...
is the answer.
No, yes, good question. It was one of the things I tested when I did the demo. It's how easy it is to do, how fast me, not a developer, could do it. So a developer can be even quicker. So the time that I found out is 15 minutes. But 15. But not to develop lots. It's 15 to learn, to install, to learn lot and deploy lot. If we are talking a developer that knows lot, 5 minutes. The route connects to the database, configures everything. We define the model, but to store in the database, we just need to put 1 line to say store in database. We don't need to do a lot of overhead work. It's simplified, so it's very, very, very quick. For example, if I came here and I said, no, I want to connect to data from a PLC here. I would just need 1 minute to add a route. How could I do it? Let's go back to the docs. I could go here and find a route, let's say a Siemens PLC. I would go to industrial routes, Siemens PLC, or just ask AI and even give my data. I have this IP, this device with these variables. It would generate for me. I would copy, I would place here, and I would just deploy, and it could be plug and play. So 15 minutes installing, learning, and doing. So very quick.
While experimenting with integrating with MongoDB, did you run into any issues that were hard to overcome?
Yeah, not a lot. Just I was thinking I need to install, define the collections, prepare everything, and then found out no, Coreflux does that already automatically. So I was thinking I need to put here insert with a data structure well defined the query. No, I found out we just need to say store this in Mongo and Coreflux handles everything. I was thinking thinking I needed to develop that, and I was in that paradigm. But no, as soon as I found out, yeah, I can just start with this line of code, yeah, it was simple. So it was a knowledge issue. I was thinking the traditional way, not the simpler way this brings forth.
What's the biggest advantage to integrate this way? Like, why this way?
Faster to develop, 15 minutes to learn and do. As I said, easy to change. I need to change, store in another database, change the name here. I want to add another device. This is a wildcard model, runs for every machine. If I had here a route to connect to a Siemens PLC, this model will trigger automatically and store in the database. So the time to develop, the modularity of the solution, it's very big. And it's very performant. This is running on the broker. So when you get new data, you store the data, you process and start very fast. We don't have problems with dealing. Sometimes there's issue in projects that we do a small proof of concept. It works. Okay, I want to do this for a full factory, for a full power plant. No, it doesn't scale. Yeah, this scales because this is running on the broker, high performant broker. So running this for one machine or 1,000 machines, it's the same code, it's the same performance. So it's another good characteristic of this system, and so we are fast to develop, but we can also easily scale the solution.
Second to last question. Our Ask AI at blogs.coreflux.org is still beta. We still trying it out. It's brand new, but it actually does work. How good is it? How well can we trust it at this stage in time?
Let's say 90%. For simple stuff, 99%. So I want a MongoDB route. I'll just ask here, how do I connect to Mongo? And it will answer quickly with an example. I can say my specific Mongo, it's running on that cloud system with this IP, and it will change. But if I ask it to build a full system, it is not designed for it. It's an assistant to help you do this. But we also have another approach in beta. This system has an MCP, so you can connect to AI agents to support coding. So I can develop with an AI agent. Still beta. You need to say, I want to use lot, I want to create an action. You need to have the basic grasp of concepts, but then when you ask for that function, for that logic, it can generate it for you. It's not as perfect as developing JavaScript and Python. We have a new language, not 20 years of knowledge embedded in the AI agent, but it's already possible. Yes, it's 90% accurate. So let's say it saves 90% of the time, not 100%, 90% of the time. We are using it for ourselves. So
and it writes lot.
Exactly.
When it writes lot, we know that it's doing something.
Exactly. If it would write Python, we'd see, no, it's making up stuff. No, it writes lot language. Doesn't develop full systems. For that, we will need to wait a few months with stuff we are preparing. But yeah, it helps a lot.
It helps a lot.
Hey!
Last question. Can you tell us the story behind your mouse?
Please no.
Can you show it to camera?
Please no. So, this is a battle-tested mouse that's been with me since college. I bought it for 10 euros because I wanted a mouse with an extra button or extra 2 buttons to play some games. But it joined me on my college adventure. My master thesis was done in a lab with developing a machine. This was there. It was my mouse there. Then home, I bought an expensive mouse, an ergonomic mouse. I had a portable mouse to bring with me, but this is still there. 10 years after, from 10 euros, still working, still functioning. So yeah, it's not portable, but it's portable enough and it works very well. Yeah.
Nice. Very cool.
Okay.
I think we're done.
We're done?
Yes.